Hello, welcome back, you guys. So in this video, let's run through how I set up the lightning impacts for the blue stuff. Um, Honestly, this is the most straightforward effects that you could ever think of. Um, there are a total of 4 layers for these effects. It's the lightning beam that comes down first, and that little flash that happens here, and then the shockwave rings, and then the stray particles that happens when the beam fades off. So let's dive right in. So let's start off with the lightning beam. This is extremely easy. Putting down a line um, in the origin. There you go. So I'm reversing this line just so that I could get the curve view to appear in the correct place. So if I were to do a color swap here and wrap from attribute curve view, put on infrared. So the resample can give us the curve view attribute by default. It's not by default. Wait, let me check. Yeah, it's not by default. So I just tick that on, and I get the curve view. And without the reverse, it's gonna be the other way. Basically the 0 to 1 value goes from the origin all the way to the top, but I wanted the reverse of it, so that I could do this guide process thing. The guide process is based on the vertex order, I think, of the curve. So if I were to not unreverse this, it will be from the origin and to the top. So that's why I added the reverse, so I could change the vertex order and have them all go from the top to the bottom. Right. So after I've done the resampling, I did another resample pass because this resample doesn't do anything. It just gives us the curve view attribute, and there are only a few points there. This resample though gives us more points on our curve. Here I'm just initializing the width for our when we do the polywire, and adding a noise, multiplying that width attribute with some noise just to vary the width a bit. So if you see this polywire, we'll do add width on the width of the polywire, and let's multiply that with some value so we can see it clear. So without the noise, it's just this boring flat look beam. So I'm just adding this noise using just a world position noise just to vary the width a bit, and then using the guide process, setting keyframes to set the timing of the lightning beam, as you can see. So this goes from 0, 1, 2, and then back to 0 to kill it. And down here I'm also animating the width. Let's have a look. Whoops. Do that. So the start is thin, and then gets thick, and then disappears. Nothing too shabby. I'm just multiplying it with the channel float and animating the parameter. Where did it go? There you go. Animating the parameter on that. And then I'm just using the polywire to generate proper polygons and coloring it. And that's pretty much the lightning beam. Super straightforward, nothing fancy. simple is sometimes the best way. So next, after I've done the blue lightning, we'll do the blue lightning particles. The blue lightning particles is basically the stray particles that happen after this disappears. The lightning beam changes into a particles because as it dissipates. So the way to do that is just taking that lightning thing that we just did. So this is a proper polygon now with primitives, with polygons. Clipping it down so that we don't go all the way down below the origin. And then I'm just time shifting it to the frame where it fully hits the ground. So that would be around 1020 apparently. And then clipping it some more and up there, just so that we can scatter some points onto that polygon. So with the orient along curve, I'm just grabbing the tangent, and storing that as a velocity. So you can see we've got these now, velocities pointing down. And then I've also modified the velocities and adding some curl noise to the velocities and reducing the input velocity by 10%. And then on this part, this is nothing fancy. This is just making sure that I don't have any velocities that go up because I want them all to somewhat go down based on the momentum of the lightning beam. All right, so this gets sourced into a popnet. So with this switch if just switches that emitter on for one frame based on the time shift frame we inputted here. And inside the popnet is literally nothing fancy. I'm just sourcing all those points and setting the life expectancy. Everything else is on default. Adding a pop wind just to have some good movements to the particles, and this is what we get. So cool. So after that, I do some post-processing to the particles. So I'm calculating the speed here apparently, and then initializing the p-scale. So this is the maximum p-scale, and in here I'm just randomizing that based on the ID. So I get less bigger points and more smaller particles. So if I do this, no, not that, but attribute create sphere points inside detail 1. So if I just view this, we can clearly see that. Let's multiply that a bit more. F at p scale. We have more of those little particles and less of the bigger particles. And under that, inside this multi scale here, I'm just telling it, so this is called a ternary operator. So all it's saying is get a random number based on this seed, and if this random expression, this random function gives us a value of between 0 to 1, and let's say if it's less than 0.9, we multiply p scale by 1. If it's not less than 0.9, then we multiply it by 2. So what that gives us is we increase the size of just 10% of the particles by 2, as you can see. Pretty cool. Before, after. All right. So, and then adding the color, initializing. So with the attribute adjust color, if we put down an attribute adjust color sop, and we go through here, and we just do an enable color correction, and we disable the adjust value. And under gain, if you see what this gain does is just increase the brightness of our color. So what we can do to randomize this is clicking on this dice here, dice icon on the parameter, and this will automatically give us this node, which creates an attribute adjust float, and we're adjusting an attribute called gain. So that's all I did. So this created it for us, and then based on ID, I'm just, hold on a sec. Based on the IDs, I'm reducing the gain of some of these particles, so that we have less brighter particles. And for this wrangle here, all it's doing is as we reach our depth, the brightness of our color dissipates, right? It reduces, it decreases. So that's all I'm doing for this wrangle. Cool. Next would be just initializing our alpha. That's just for the shader that we will be applying on our particles. Awesome. So that's the lightning particles. If you see what we have so far, I'm just gonna view that. The lightning happens, lightning disappears and turns into particles. Cool. So next up is the lightning rings. So this is all done procedurally using the pyro tools from Houdini. It was quite fun to make these, as it's pretty fast and it's extremely art directable. Zoom. So we have 2 inputs here. So this input is the one that happens at the top, and this input here is the 3 shockwaves that happen at the bottom. So all I'm doing is creating a line, and it's important to have 3 points, because all I need is just 3 points. But if you have a look at this, increasing this and the amount of points, I get more rings, and we change the length, we get this. So it's pretty cool. So all I'm doing is getting this line, setting the amount of shockwave rings that I want. This resample does nothing. It's not giving us any points. However, it's giving us the curve view attribute that we need. So in here, I'm just moving the points around just so that I could fit them in the position that I want them to be in. Yeah, I know this is not procedural, but that was the easiest way I can think of to adjust the position of the shockwaves. So this is the cool part. So the pyro burst source node, pyro burst source, under the burst animation, if you haven't seen this before, this is a pretty cool node. Under the burst animation, we can set the start frame. For example, we will start at 1008 frame, and then it starts at the 1008 frame. Let's set the burst type to shockwave. Cool. Best rings. No, let's use shockwave. Cool. But we obviously don't want them to happen at the same time. So the cool thing about the Powerburst source node is we can click on the dice again next to the start frame, and this start frame we can randomize the time that these shockwave appear. But we need to make it art directable so that, as you can see from our reference, the lightning, the shockwave that happens at the top happens first, and then it sequentially, so it goes, it goes this way, boom, 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 boom. So we're not, we're not gonna make it random. We don't need something random. We need something that we can control. So all they've done is, you remember that curve view attribute that we have, we can fit that into our own start frame. So in here, oops, I'm just using the attribute remap. So if you see again what the curve view looks like, do ram from attribute, infrared, and curve view. So we have this 0 to 1 normalized range value. So 0, 0 0.5, and 1. We can remap that. So because we know that our curve view attribute goes from 0 to 1, we can remap that into an attribute called start frame. And I want, so if you see here again, what's going on? Sorry, my viewport is dying. Okay, cool. So the 0 happens at the bottom, 0 0.5 is here, and 1 is on top, because this is based on our color. This is 0, 0 0.5, and 1. So what we need is actually the reverse, because we want the one on top to happen first. So input min, we will set it to 1, input max we set it to 0. And then the output min, which is the 1, will become our first, for example, 1008. And then the output max will happen 1016, let's say. So the value 0 will become 1016, and our value 1 will become 1008. And anything in between that will be interpolated linearly or based on this ramp. Cool. So if we plug this in into our Pyroburst source, 1008 happens, and on frame 1012, the 0 0.5 value happens, and then the bottom happens on frame 1016 as we set here. That's pretty cool, eh? All right. So now we have that. Boom. Zaboom. So that's a good way to manipulate our start frame based on a curve and an attribute called curve view. Very, very fun. So next, I want to have this kind of look where, let's find a good frame. Maybe around this part. So the top part is actually smaller in radius than the one at the bottom. So how I did that is, you guessed it right, fitting the curve view into p-scale. So the cool thing about the Pyroburst source node is that it can read p-scale as the initial size. So this initial size, we can use it to determine how big our burst shockwave rings get, as you see. But this initial size, if we tell it to use attribute, it'll read the p-scale attribute on the incoming input point. So with this in mind, we can just fit our curve view into a p-scale attribute. So before we didn't have a p-scale attribute, and this attribute remap just remaps the curve view into a new attribute called p-scale. And now we have a p-scale attribute. And it's the exact same thing. 1 becomes 0.4 and 0 becomes 1.7. And that's how I got this cool change in scale on our radius. Cool. Awesome. So here I'm just multiplying that down because it's just for art direction purposes. So the cool thing about the pyroburst source node as well is that it comes with the add shape noise, which changes the shape of the shockwave for more variation. I find that really cool and helpful. Side effects has done so much, added so much things to the pyro tools that makes things easier for artists to develop effects. And I'm all for that, and I find them really useful. Awesome. So now we've got that. I'm just spitting out, just setting some values here so that I could get a good look on the sim. On the shockwave. I added the scale over duration just so that the density gets scaled down to 0 as it reaches its peak radius. That's for the shading purposes. And awesome. There's nothing more here, I think. Oh, this is cool. So what I did here is just, we have a density attribute that gets outputted from the pyroburst source. I'm just fitting that density attribute and remapping it into an attribute called mask and doing the invert of that, because I want to create some noise as the shockwave reaches its death. As you can see, we don't have noise at the start. The start looks very straight, but as it reaches its final radius, it gets bent around and things like that. Cool. It's the same thing here, except since this is just 1 point, all I'm doing is just burst animation, setting the start frame manually on the pyroburst source node. All these are the same on here, and if you merge them all together, they look like this. And these are all, again, just me setting the P scale, colorizing them, changing the gain so that I could use it for the color correction on the color, and then setting the alpha for the shader. All right, let's have a look. That's pretty cool. Awesome. So that's the lightning ring. Let's see again. This is what we have so far. Pretty cool. I'm not adding any collision for these. I don't really need to. And the blue flash is the final piece that we talk about for the lightning stuff on the blue stuff. The blue flash is just this little thing. As I recall, I'm not sure if we have that on the... We kind of do, I think. Yeah, we do. So all I'm trying to mimic is this nice sparky flash hit here. And all I'm doing is just using the pyroburst source again. Man, these tools are amazing. So they're all just particles, and I'm just using them, rendering them as particles as well. As you see here, I'm using the same old tricks, colorizing, setting the alpha, using the gain to adjust the color correction and all that. So that's it. That's really it. There's nothing special about the setup for the lightning things. They're all pretty straightforward, but I hope you learned some cool stuff on this video, because I find that these tools that Side Effects has provided are extremely useful when you know how to really use them to their fullest potential. Cool. So without further ado, I guess we'll see you on the next video. All right.